Hey guys, welcome back to our channel, Little Tap.
Hey guys, what are we going to build today?
A fractal tree.
Yeah, we're going to build a fractal tree. Let's get right into it and show some of the cool things that we've done with it. This is the basic single tree. Now what we've done is we've also done a couple other projects where we took that and animated it. So here's that same tree with just a little bit more code on it.
There.
Yeah, but that's actually the dancing tree, which we were going to show in a minute. I wanted to show the animated tree. So let's
So now
make
I have to do all my work again?
Well, no, let's make it stop dancing. It's like, stop it, tree, stop dancing. Here's what we did to make it dance. I'll show you that. We basically were branching a random number here. So this is actually just supposed to be 0.67. Do you see that 0.67?
Yeah.
Oh, look. See, it was doing that while we were doing it. So now what this tree does, and actually I think we can, we made it faster here. So let's make it 0.01 seconds. And what else did we do? We put this at 4. There we go. There, do you want to make it big now, Eden?
Sure.
So that's the first animated tree, right? And so what it does is it just changes the angle, and that's one of the variables in our program. And that's all it does, is it changes the angle back and forth. Now the next program that we wrote
I'm so excited for tomorrow.
with this is was this dancing tree. So what we did for this one is we took the random values here for the sides of the tree. So the tree actually moves back and forth. It almost like sways randomly. Okay, so when it sways randomly, what's it do? It dances. What do you think about that one?
It's okay.
No,
But I think we can do better.
well, this is the best I can do.
Oh.
It's great.
It's great!
Yeah, so it's a dancing tree. Please make sure to like and subscribe if you think your kids will enjoy learning too. So let's look back at the simple tree that we have, and I'll show you what kind of things you can play with. So if you take this project, you wanted to play with some of the variables, you can change the branch size. So right now, what does this look like? A symmetric tree, but if we change this from 0.67 to 0.87, what happens to our tree? Oh, isn't that cool? So what that did is it got all piled up on one side because we changed just one of the branches. That's kind of a really poofy tree.
Can you change both of the branches?
Yeah, we can make them both 8, 7. So these are just, you know, some things you can just play with. If you want to see what are the fun things it can do. Whoa!
I don't see it.
Yeah, it's kind of going nuts. I don't know. So let's just put that back at 6, 7. So if you go under 6, 7, what happens? So like, let's do
5, 7.
4. Okay, 5, 7. It's a tree, but it's a little bit skewed that way, right? Let's do a little bit.
Can we do 4, 7?
Yeah, let's do 4, 7.
And then 3, and then 2, 7, and then
See how it's kind of angled one way?
Let's try 3, 7.
So that's how we made it dance, is we just put random values in here, and it was swaying back and forth.
What
Anyway,
is 1,
let's look
7?
at-
What's 1, 7?
Just one branch. So let's just put 6, 7 back. And some other things you can play with is the scale. That's how big the tree is. So if you want to make this tree tiny, you can put 0.45. Whoop, little tree.
Can we see 1? 0.1.
0.1.
Yeah. See how small does it go? How small does it go?
As small as you want. Boop. Okay, let's quickly go over this algorithm for the recursive tree. So recursion works really well when you want to do the same thing over and over again, but just with a smaller subset of the problem. So let's look at the tree that we're going to build and how that would look. So first of all, you would start out with a branch, and then from here you would draw another line, and then what our algorithm's going to do is it's actually going to draw a branch, one going off in one angle and one going off in another, and then for each one of these it's going to get a little bit smaller, but it's going to do the same thing. So on each little subset here you're going to have a smaller and smaller branch. And that works out really well with recursion because we can define a function called branch, and all we're going to do is draw a line that's of the size that we want. And then if the size is still visible, so essentially these branches are going to get so small that you won't be able to see them, and that's our stopping point, right? So in recursion you have to have a base case. Or in recursion you have to have a stopping point, right? So you can't just draw lines forever. So if the size is still visible, then we're going to rotate and draw a line in one direction, and then rotate again and draw a line in the other direction. And we'll just do that till the size becomes negligible. So there's no use in drawing tiny pixelated lines because they're not going to show up. And that's essentially each iteration gets 2/3 smaller through. So that's your recursion. And one way to look at this though is the recursion actually works in the code by following one path all the way down. So how it's actually going to build the tree is it's going to build it with this line, and then it's going to go off in this direction, and then it's going to go off in this direction, and then it's going to go off in this direction until it's too small. And then it'll eventually start building the other paths going back. So you can see this really well when you run the program without the turbo mode turned on. You can watch it iterate through the fractal in the recursion. See how it goes down one path. Start over. So it goes down one path, and then it starts building that out and going to the left. So how that works, if you see in the code, is it's essentially calling this branch, and then it goes through and calls itself again, and then it hits that again, and then it calls itself again and hits that again. So it's always going down the positive path until it's ends up at the end where length is less than or equal to 3. And that's where it will start going down the other path. As soon as this is exhausted, then it goes down this path. So let's get into the code. Okay, so the first thing you'll start with is when clicked. Right, so can you find your when clicked?
Events. When clicked. Over there. Done. Now what?
Okay. Now what we're going to do is make a block. Do you see my blocks?
Block.
So a block is a function that you can
Blocks.
call. You say make a block.
I accidentally made pen. Make a block.
And then, so we'll call it init. I-N-I-T. Can you just type I-N-I-T?
Init. I-N-I-T. I-N-I-T. Done.
Put the T in.
I did.
And then hit OK.
Okay. I mean enter.
No, enter doesn't work. You have to hit or click OK or type. You can just push it. Okay, cool.
Okay.
So now you can drag. That's the definition of init. You can't put it under there. Put it over to this side, and then drag your init under here. You see that init?
Init.
Okay, so that's where we'll start
I
some
delete
variables.
this?
No, you have to keep that in there, and we'll
Why?
define that in a minute. There's a couple things that we'll put in, and then the other thing is branch. So we need to make another block, red block.
I spell branch.
B-R B-R-A-N-C-H.
Where's the C? Branch.
Yep. And then here, just add.
OK.
Look, don't hit OK yet. So hit add an input.
Add an input.
So this is going to take a value that we give it
Number of text.
and call it length. L-E-N.
L-E-N.
So it'll be the length that we want it to be.
L-E-N is not length.
It's short for length. L-E-N.
Where's the E? L-E and then N.
And then hit OK. And then pull that length, that branch over here.
Branch.
Do you see the difference here? It has a white value.
Okay, let's move
So
on
type
to
85 in that.
85. 85.
Okay, so that's how big the tree we're gonna make is. This is the thing that draws the actual tree. Okay, so what are we gonna do? So we're gonna start off with, what do we do when we want to draw something?
Pen.
Pen, yeah. What do you have to do with your pen? Pin down. So you gotta put your pin down.
This is like Blockly in our other video.
Yeah, it is. It's pretty much exactly the same, right?
It's also in something called pen, and you do pen down and pen up.
So put your pin down, and then we have to move a certain length. So what we're doing when we draw our tree is we're drawing a line, one line at a time, right? So we're gonna make that line a certain size. So we put our pin down and we have to move our pen. So there's a function called move. Do you see under motion? Big baby
Move
talk.
10 steps.
Yeah, so let's pull move in.
Move 10 steps goes that.
We're going to multiply two numbers together to figure out how big it should be. We're going to multiply length. So can you grab length, that's that circle here, and put it in one of those two boxes. And then scale. Scale is a new variable. So we'll have to go to variables and click make a variable, or you can just drag scale in there. So scale.
Go.
Yep. So that's going to move your pen
Here, let me
to a
move
certain
my pen.
spot. Now, when we're done moving our pen, we got to do what?
Zoom it. Make it bigger first.
Well, what do we? So now we got to lift our pen up, right? So if we go back to
Events.
the
Pen.
pen, can you find pen up?
Pen up.
Okay.
Big pen up. Now I need to move my pinky down.
So the next thing that makes the tree so pretty is we set the color of the pen. Okay, so the color is going to be a math formula. You'll see that? There's a math function called mod, and all it is a division, a remainder. So pull that mod in and put it right where that 50 is. Yeah. So we're going to take the Y position. You see under motion, the Y position. That's where the pen is on the paper. Oops. And we're gonna mod it by 100.
What's the sound? Oh, sound is pretty.
Well, yeah.
Move it by 100.
Mod by 100. So there's only 100 colors in Scratch.
Now what?
Yeah. Yep. Perfect. So that'll make it colorful. And now all we're gonna do is finish this off. So when you draw that tree, you draw one branch, and then what happens to it? It splits into two, right? Yeah. So when that branch splits into two, what are we doing if we're...
It's like one branch turns into a branch with different branches on it, and those branches get new branches on them, and it like goes on and on. It's just branches with new branch. It's just one branch with more branches and more branches and more branches, and obviously the branch is the trunk, the first branch.
Yep. So it's saying if there's more branches to build, turn this way and branch again. Do you see the word branch? And then it says turn the other way. Do you see the arrow?
Yeah.
Turn one way and branch, and turn the other way and branch. So let's find the if. So this is basically if there's something to do. And so saying if there's something to do is basically if if the length, so that's what we said, if the size is greater than 3, then, now do you see under motion, can you find the turn direction? Turn right? Yeah, you want to pull that in? Okay. So where's the other direction?
I will tap that when I just didn't come.
Okay. And then we need to, in between here, we need to call the branch function. Do you remember where that is?
Branch.
So we want to draw a branch after we turn.
This?
Then after you turn the other one, branch. Actually, we don't want it to be the same size. Each branch gets smaller, right? So how we say get smaller is you can do 0.667 times length. Okay, so that's going to be only 2/3 the size of the original. And we'll put that in this branch. Okay, so we're going to turn one way and draw a branch, turn the other way and draw another branch, right? Instead of 15 degrees turn, we want to turn angle degrees. So we're going to make that a variable. Do you know what a variable is?
No.
It's just something that we can set, a number that we can set at the beginning of our program, so we don't have to put actual numbers in. So if I say angle, turn angle degrees, right?
That means any degree.
Yeah, that means something that we set. But where are we going to set that?
Any.
Look what we can do. We can go over here and say set angle to 30. And that'll be how far the branch moves over each time it branches out. And then we have the size. This is the scale. This is just a way to make the tree bigger or smaller based on what it is. Also, when we start this program, what do we need to do? We need to erase the whole screen, or else it'll just get all jumbled up. So there's a block here called erase. Do you want to pull it down? Okay, now that we have the basic recursion defined, we just want to add one more little piece to this program before it will finally work. If you look at what the program does now, it will draw one side and then kind of create a funny squiggle once it gets to the end of that. And what's going on is, in recursion, what will happen is it will go down all of one path first and then execute the next section. So we have two branches, and ideally it would create the positive and the negative side of the branch at the same time, because that's our algorithm. But what it's really doing is it's going through this entire branch, first branch, before it gets to the second. And how the coordinate plane works is it's just saying move a couple of steps and turn, move a couple of steps and turn. By the time it gets to the very end of the first path, it has no idea where it is. And so what we need to add to this program is a way to track the current coordinates that it has before it jumps off and loses track of where it is. So what we're going to do is just implement a quick function that will keep track of the basically the x coordinate, y coordinate, and the angle before it goes out and branches a million times. To do so, what we'll do is we need a couple helper variables here. So we're going to make a list. And like I said, to keep track of our position, we need probably xpos. And this is a list, so it's an array. And then ypos. So there's your x and your y. And then we need the angles, which I'll call directions. Okay, now that we have those, anytime you create a list, you want to make sure that that's clean before you run your program. So in our init, we'll just say delete all of, and we'll say delete directions, delete xpos, and delete ypos. Okay, so let's look at what we need to do. We need to make two quick functions here, or blocks, and one we'll make to save the coordinate plane and one we'll make to restore the coordinate plane. So I'll do make a block, and I'll call one save C for save coordinate plane, and then I'll make another block called restore C to restore the coordinate plane. Okay, so we don't have to worry too much about this right now, but we'll implement that in a second. So where does this go in our recursion? Basically, before and after we branch, we should save and restore our coordinate system. Okay, so we'll just put a save here, and then right after we branch, we'll restore. And then we'll put another save before we do our second branch. And then we'll restore it at the end. So I haven't added a whole lot more logic to the recursion, just I'm saving the coordinate plane. Let's go ahead and implement these functions here. So saving the coordinate plane is pretty simple. We're just going to add the current x position, y position, and direction into the proper arrays. So let's go ahead and we will just do an add. And one of this will be the x position, one will be the y position, and one will be the direction. And what we can do is we get that out of the motion up at the top. We have here x position, y position, and direction. Now let's go over to implementing the restore coordinate plane. Now for that one, we basically have to put ourselves back at the x and y position and the direction. So that's actually pretty simple too. There's a go to xy, and there's a point in the direction of. So we'll use those two. And we just have to pull the items out of the end of the array. Okay, so this gets a little bit longer of an expression, but it's not too bad here. So we'll go back to the array options, and we're going to pull out item number of So we're going to pull out an item of xpos and an item of ypos. And an item of the direction. Now the item is not the first item, it should be the length of xpos, because we want to get the last item. So we're going to do here, here, so that'll fill in the length. So at that point we have restored the coordinate plane, and all that's left to do is to delete the things in the array. So we're going to do delete, and then we'll do the length of xpos of xpos, and then I'll just duplicate this a couple times. Oops. And so then we're going to delete the length of ypos from ypos and the length of directions from directions. Let's go back to these variables and just make sure that they are not going to show up anymore. So we'll take directions, xpos, and ypos off. Now let's go ahead and run the program. Yay! So there's the tree, and so as you can see, what's happening now is we're getting both sides of the branch. So if we don't save the coordinate plane, it basically goes off in one direction, gets to the end, and then it tries to do the other direction. In this case, now that it's saving the coordinate plane, we have both directions and we have a tree.
Make sure to like and subscribe. See you next time. Bye.